ladies and gentlemen, boys and girls. My name is Mr. Du, and science is my business. You are welcome to Mr. Du Scienceworld. And today we are going to look at our continuation of equilibrium. Now, what type of equilibrium are we going to look at? The last time we looked at the translational equilibrium. So today we're going to look at what? Rotational equilibrium. And when we talk about a rotational equilibrium, what do we mean? A rotational equilibrium is what we refer to as what? The torque, or what we call the moment of the force. Now, if I have an object, say this object, and I'm trying to rotate this object at a fixed point, and I'm trying to rotate it, then we can find the what? The torque at that particular what? Fixed point. So let's take for example that I am having this. We are talking about the torque. Okay. So let's look at it from this point. That I am having a beam, and with the beam that I'm having, there is a fixed point here. And I'm trying to rotate this beam at this fixed point. What are the things that I need? To be able to rotate that fixed point, one, I need a force. And not just the force that I need, I also need what? A distance between the what? The fixed point, or what we call the axis of rotation, and the what? And the force that is applied to rotate the what? The beam. So now let's look at it and see. Here is our fixed point, so we will call that one our axis of rotation, or we call that as a fulcrum, or you can also call it what? A pivot. A pivot. Any of these three things can be used. Now let's say that there is a perpendicular force that is applied at this point here. So this is our force here is applied. The distance between the fixed point and the what? And the force. The distance between the two is what we refer to as the lever arm. And this lever arm is the what? Is otherwise known as the distance. Which is the distance between the point where the force is applied and the point at which we want to rotate the what? The object. So let's quickly try and see from here. The next question we need to ask ourselves is that then how do we calculate for the what? For the torque in this. To calculate for the torque, we simply say that a torque is a product of the force and the what? The perpendicular distance between the what? The force and the what? The fixed point, or the axis of rotation. So we can just simply say the torque is now equals to a perpendicular force multiplied by a distance. So immediately we are able to see this, then the next thing that should come to your mind is that what about if now the force is not perpendicular, but the force is at an angle? So let's assume that this force is at an angle of sine theta. Then immediately our torque is now going to be the force multiplied by sine theta multiplied by what? The distance. So this is when the force that is applied at what? At a perpendicular what? Angle to the what? To the distance. And now here is when it is applied at an angle which is not what? Perpendicular. It's inclined. The force is inclined. So let's try and now apply this in solving some problems. Okay. Problem number one. Let's try and use the same beam that we have and give it values, and then let's try to do calculations and let's see. So let's assume that we are given this beam and the beam is, say, 10 meters. So there is 10 meters beam, and now there is a fixed point which is here, and that fixed point is just at the edge of the beam, and that is the point P. And we have a perpendicular force that is applied at this point, and let's assume that force is what? Is 100 newtons. Now we need to find the torque here. To find the torque, how do we find this torque? We will just simply say that our torque, we state the formula. We know torque is simply equals to the perpendicular force multiplied by what? The lever arm. Now what is that perpendicular force? It is 100 newtons. Multiplied by what is the lever arm? It is what? It is 10 meters. Therefore this is going to give us 1000 what? Newton meters. How did I get the unit? Force is measured in newtons and distance is measured in meters. Therefore, Newton what? Meters becomes the what? The unit of the torque. So now we've gotten the torque in this. Let's look at another way and say, okay, now we have the same beam, but this time around, the force is now applied at the center of the beam. The force is applied at the center of the beam. So let's say we have here, our force is now here, 100 Newton force. It's now applied at the center of the beam. And we need to find the what? The torque here. To find the torque, remember that our D is not just the length of the beam, but it is rather what? The distance between the point where the force is applied and the what? The axis of rotation. Here is our axis of rotation, and here is the point where the force is applied. Therefore, if the entire beam is 10 meters and the center is where the force is applied, then our lever arm is going to be what? 5 meters. And we will therefore say that our torque is therefore going to be 100 newtons multiplied by 5 meters. And this is now going to give us a torque of 500 Newton meters. We've been able to calculate for that now. So this becomes a what? A torque. Let's try and look at it from another point, another example, and see. Okay, this time around, the force is now applied at the same point where the rotation is. So the force is applied at the what? At the point of rotation. At the point of rotation. So we are assuming from this point that our force is now here on the side. We have the force here, 100 newtons. And now we need to find the torque. So what do we do? Well, straight away we will take it and say that our torque is the perpendicular force multiplied by the lever arm. What is the force? The force is 100 newtons multiplied by what is our lever arm? Our lever arm is what? Is 0, because there is no distance between the force and the what? And the axis of rotation. Therefore, it is what? It is 0. So that is 0 meters. And therefore, that is going to give us a torque of what? 0 Newton meters. Getting a torque of 0 Newton meters does not imply that the force is not what? Pushing on the what? On the beam. The force is actually what? Pushing the beam at the point P. But the only implication here for this 0 torque is that what? It is not causing any what? Any rotation. So there is no torque. There is no torque. That is exactly what we have to think of. Alright. now look at a problem where this time around the force is not what perpendicular, but now the force is at an angle. So we're still using this beam, but this time around, let's take it that our torque is applied here. So that is the force, and the force is 100 newtons, and let's say it is 100 newtons sine 37 degrees. So it is at an angle of 37 degrees. So if it is 37 degrees, then we will need to calculate for that. So to find the torque, we know it is not all the 100 Newton force that is applied that is going to cause a rotation to the beam. It is just a portion of the what? Of the 100 Newton. That is going to cause what? The rotation. So let's do that now. We know the torque is now equals to the perpendicular force multiplied by what? By the distance. But now, the force here that we have is not perpendicular, it is at an angle. So our torque is now going to be 100 newtons sine 37 degrees multiplied by the what? The distance, and the distance between the point of the force to the axis of rotation is what? Is 10 meters. So what are we going to get as our torque? Right. Let's take our calculator and let's see what we're going to get. So this is 100 multiplied by sine 37 degrees multiplied by 10 meters. And once we do this, we are getting our torque here to be 601.81 Newton meters, which is just simply going to be 6.0 multiplied by 10 exponent 2 Newton meters. And these become the what? The torque. In the what? The torque in the system. As you can see, that the distance here is 10 meters. When the force was perpendicular, we got 1000 Newton meters. But now that the force is what? Is inclined at an angle of 37 degrees, we are getting what? We are getting 601 or 602 Newton meters. So the angle has effect on the torque. Alright. Please, if you have not subscribed to my YouTube channel, do subscribe to the YouTube channels and click on the notification bell so that anytime we release any new video, you'll be the first person to watch it. Thank you and see you next time. We are going to continue with the talk by solving more problems. So look out for the next part of the talk.